And now let's talk about the scrubbing technologies. The scrubbing technologies is when we use a solvent and we use a liquid to remove the CO2 from the biogas. And there are different techniques for that. As I told you, we can use a physical solvent, and in this case we can consider the water or organic solvent, and we can use also the chemical solvent, and in many cases we use amine, and the amine reacts with the CO2 to kept it from the biogas, and during the steps of regeneration we release the CO2 from the amine, and with that we can recirculate the amine again, and it is very similar with what we have in the hydration system. It's very similar. I will not talk about the amine system, but we'll talk a little bit about the water scrubbing and also the organic solvent. So what we have here is that the biogas goes into a tower, to absorber tower, and you can simulate absorber tower in the Eisenhower seas or in many process simulation software. And the absorber can be a tray tower, or it can be a package tower, and we send the water, sprays the water against the biogas. And because of the increase in the pressure of the system, the CO2 dissolves in the water, and it is very similar with what we have in the Coke, for instance, or in the soda. It is a pressurized liquid, and when we release the pressure from the bottle, the CO2 is starting degassing, is starting dissolving from the liquid, and it is the same principle. So at some pressure that can range from 4 to 10 bar G, the water will dissolve the CO2, and the water plus CO2 will go to a flash drum or a flash vessel, and in an intermediate pressure we can release the methane that is also absorbed during this process in the absorber. And we use the flash gas to recirculate to inside of our column in order that we can improve the recovery of the methane. And the water with the CO2 goes to a stripping column, and in this stripping column the objective is to release the CO2 from the water, and release other contaminants that are also dissolved in water. And it is very interesting, this kind of process, because if we have H2S, it is soluble in the water also, so we can remove the H2S, and the volatile organic compounds is soluble also, so we remove that, and we can use the air to do the stripping of the water and regenerate the water. And in terms of operations, we must monitor the pH of this water, and time to time we need to do the blowdown, or we have to have a blowdown continuously, because we are not able to remove 100% of the CO2 from the water. And to not saturate it and to not lose the quality of the gas, we need to renew the water. We need to add fresh water to the system, and because of that, this kind of technology has an intense water requirement. So if you are in a location that the water is very expensive, or if the water is not available, eventually it will not be the best kind of technology to you consider for your process. In the other hand, it is very simple operation. Technically it is relatively simple method, and you don't need to have a heat source for regenerate the water. You just need a blower to use air to remove the CO2. So there are some kinds of advantage. And in the other hand, the disadvantage is that the water is less selective than other solvents. So when we use the organic solvents, our target is to increase the performance and don't have this kind of worry about using water. And when you discharge the water for you cannot not discharge the water for the river, for instance. You need to have some kind of pre-treatment to comply with the requirements. So this is some kind of issues that you must worry about when we are talking about water scrubbing.